Hello everyone, welcome to the NN Classroom. Today, I'd like to share with you a past paper question from 2019, Time Zone 2 in May, question number 24, relating to the topic 8, exit and bases, especially in terms of pH calculations, quite common. Let's see, asking, what is the pH of 0.001 mol per dm cube of sodium hydroxide? The key feature for this case is that what we are now given is a base. So that means, for a strong base as well particularly, that the concentration, first we can better change it to a scientific notation form, so that will be 1 times 10 to the power negative 3 mol per dm cube of the sodium hydroxide. Why we need to swap in this presentation format is that because of a pretty basic logic that we can simply put the index down, so that is so-called the pH that we use to calculate, right? Because as we know that a really basic concept, if given the proton concentration is, let's say, 1 times 10 to the power negative 2 mol per dm cube, then the pH is simply equals to 2. So this basic fundamental concept is demonstrated the first time everyone when they're learning the meaning behind pH, right? Is that to take the negative log. That means bring down the index to the linear scale, right? So that's why we better to figure out this scientific notation form. But then this is going to be a base. So that means a strong base as well. So that means the concentration of the hydroxide ion is going to be the same value of OH minus in terms of concentration because of a strong base. So that means by simply take the negative log of this concentration will only give me not yet the pH but pOH, right? So in this case the pOH is which is going to be 3, right? After knowing the pOH, then how can we get to the pH? Finally, we apply to the final shortcut equation. Simple is that pH plus pOH, which is going to be equals to 14, assuming under room temperature 298 Kelvin, right? So this is a really famous shortcut applying the ionic products of water to deduce it, right? Of course, we no need to do the deduction, but just to apply. So in this case, the pH will then be 14 subtracting 3, so which is going to be 11. So that's why the answer goes to C. Yeah, remind that this is going to be a pretty much more making sense answer, because as we can see, sodium hydroxide is an alkaline, right? Alkaline should achieve a pH that is greater than 7. So that's why don't stop in here and say the pH is going to be 3. That doesn't make sense, because for A and B, these two choices is going to be an acidic situation. And only for C and D is going to be a basic situation. And obviously now we are given a base, right? Sodium hydroxide, a strong base. So that explains why in 3, that means choice B is just a misleading choice, right? Because what we are now calculating reminds you that if it's a base, we simply take negative log, so that only gives me the pOH first, not yet the pH. So that's how we need to further subtract it by 14 in order to arrive the pH, and that will be a making sense answer, because that should be a number greater than 7.